So let's look at how we can test polar equations for symmetry. If I have something that's symmetric with respect to the polar axis, okay, so in other words, my x-axis, as you can see that my angle just becomes negative. If I have symmetric with the line theta equals pi over 2, remember that's 90 degrees. And then as you can see, I replace my theta by pi minus theta, right? So in other words, because you know this whole distance is pi, right? Right. And then if I want to have it symmetric with respect to the pole, so remember this distance is r, so I just move it to the other side by negative r. All right, notice this says student's graph. This is typically an activity that I do in class. If you like, and I know you like, you could print this slide and then you could follow along. You could even put your name in the blank if you want to, and then just put it in your notes. So basically what I want to do is I want to graph this polar equation and I want to see what the graph looks like. So to do that, I plug in these angles here, and just the angles that I chose. So I plug in negative pi over 2. So if you remember, this is an odd function, so the negative comes out. So negative and a negative becomes positive, you remember? And I get this value of 2. So this is like my x, y, but in this case, my angle theta and then r. And so I can plot that value. So I know where negative pi over 2 is. And then I go out 1, 2, and I put a point. And continuing right along, if I get sine of pi over 3, square root of 3 over 2, and then when I add, I just put this in my calculator so I'd kind of have an idea where this value would go. And so once again, negative pi over 3, and then not quite to 2, I put a point. All right, and so just continuing along, and I'll bring each one of these up. You could probably pause it because I'm going to just kind of roll through these. But this shows, this is a good way to learn how to actually graph, to go through this example. And then the next one, there right there. And then the next one, pi over 6, and at 1/2. And then the next one. And then finally, the last one, I'm back at my actual pole. If I, in this case, reflect these, okay, so in other words, I could go through and find all of the values on the other side, or I can just see that this is an actual reflection, and then what I get, even though that's kind of ugly, is the graph should actually look like that, okay, so a cardioid. So these are just some weird, you're going to see all these, some weird different graphs, and then these can be shifted based off of, depending on if you're doing 1 plus sine, 1 minus cosine, 1 plus cosine, and you can see what's happening to the graph. And so these are characterized by these following equations. All right, if I want to graph this one, now I'm just going to graph them very quickly for you. I once again plot some points, and as I see, this is a limacon with an inner loop, and I can see what happens when I change from negative to positive and from cosine to sine. And so this is what the equations look like. The next one with an inner loop. So in other words, this one does a loop-de-loop and kind of a little circle there. And so once again, based off of changing negatives and positives and sines and cosines, gives you these types of graphs. And then if you, for Valentine's Day, hey, you could send your girl, or your boy, you could send them a rose. And you could tell them to switch to polar mode in their calculator and to graph this one. And look what it looked, isn't that special? So see, and you can even add petals to it. So that's kind of cool. And you thought you'd never learn anything in pre-calculus that you could actually pick up chicks, huh? Pick up dudes. Hey, there you go. All right. And so the roses based on these type equations. And then finally, this last one kind of looks like a, the first thing that you're seeing if you're wondering why they're doing two graphs is I do one side and then I just reflect the other side. Looks like a propeller. And so that gives me these equations. And then finally, last, this one's kind of a little weird, this e raised to my angle over 5, and I get this spiral. All right, so just kind of an overview, the classification, the polar equations. This is probably the main ones that you need to realize is how did we get the line? Remember, we took tangent on both sides. The vertical line, because my cosine is x. My horizontal line, because sine is y. And then if I'm centered at different circles based on where they're centered at, okay, and what the graphs would look like. And these are just kind of for funsies, okay? You won't be tested on these last equations, but once again, just kind of for those of you that have an interest in some weird looking graphs. And there's a little history right there. Feel free to read it. And we got something coming in on ESPN. All right, and that finishes this section. Not too bad. Just the first part where you actually have to solve, go through the equations and solve to get it, or where you can actually graph it in your polar coordinate system and figure out what the graph looks like. And I'll see you next section.